Solving logarithmic equation with one logarithmic form. So solve 3 log x equal to 10. We only have one logarithmic form. So isolate log x first, meaning get rid of 3. Divide by 3, divide by 3 both sides. So log x equal to 10/3. As you can see, this log does not have any base, meaning this is a common log. Default base hiding is base 10. So you can consider there is a base 10 hiding. Problem with this equation right now is x is inside the log and you want x to be outside of the log. The way you do that, express this logarithmic expression in exponential form. So log expression is on the left hand side. Keep the base of the log as a base of the exponential form, then swap the rest of the expression. So 10 to the power of 10/3 equal to x. One thing when you deal with a logarithmic equation is constraint. So log cannot have negative value inside. So constraint here in the beginning is x has to be greater than 0. And when you get the final answer of a value of x, you're always checking against it. So whatever this number is that greater than 0? It is. It's positive. So this is the final answer. If you need to get equivalent decimal value, you can type into the calculator, get the answer. Solving logarithmic equation, same style, we only have one log. So isolate log first. So this one is natural log, same deal. Let's get rid of 2 from left hand side, subject to both sides. 3 natural log of 2x equal to minus 16. Let's get rid of 3 on left hand side. Divide by 3, divide by 3 both sides. Natural log of 2x equal to minus 16 over 3. So problem right now is x is inside the log, natural log. So when you try to solve for x, you want x to be by itself, not inside the log. So you gotta free x from the log. The way you do that, express this logarithmic form using exponential form. Natural log means we have a base hiding as e. Base e is hiding. So when you try to express that using exponential form, since you have logarithmic form on the left hand side, you need exponential form on the left hand side. Base is e, keep that as a base of exponent. Then swap the remaining expressions. So e to the power of minus 16/3 equal to 2x. Solving for x, divide by 2 both sides. E to the minus 16 over 3 all over 2 equal to x. That will be your final answer. Again, if you need to get equivalent decimal value, you can just type this expression into calculator. Another version of logarithmic equation with one logarithmic form. So the difference is this inside expression of the log has a power. Also, this one has a base as a 2. We specify the specific base other than common log, natural log. So let's take this exponent out as a coefficient. We already have coefficient as 3 of the log. So when you take a 5 out as a coefficient, we multiply 3 times 5, it becomes a 15. Log base 2 of x equal to 45. We need to isolate log. So let's get rid of 15 by dividing by 15, dividing by 15 both sides. Log base 2 of x equal to 3. Again, you need to free x. You want x to be outside of the log. So let's convert this logarithmic form using exponential form. Base is 2. Keep that as a base of exponent. Then swap the remaining expression. So 2 to the third power equal to x. 2 to the third power equal to 8. So we got the final answer. Again, you have to check, always check if this final answer will not violate this constraint of domain. So if you look at the original expression, we have a log base 2 of x to the 5th power. So we need to make sure x to the 5th power has to be greater than 0. Becomes x has to be greater than 0. And 8 is greater than 0, so everything is okay. Solving logarithmic equation with more than one logarithmic form with the same base. So if you look at it, solve log base 3 of x plus 2 minus log base 3 of 8 equal to log base 3 of 20. Log, log, log. We have all same bases as 3, but everybody is in logarithmic form. So let's condense two logs on the left hand side. Log base 3 of x plus 2 divided by 8 is equal to log base 3 of 20. So we have one log on the left hand side, one log on the right hand side, and they do have exactly the same basis. So inside the log expression should be equal to each other. Solve for x. Multiply by 8, multiply by 8, x plus 2 equal to 160, subject to both sides, 150. Again, we have to make sure this is within the domain. So if you look at this log expression, inside the log expression has to be always positive, meaning x has to be greater than minus 2. So you want to double check, is 150 as a final answer, is that within domain? And yes, it is. So that is our final answer. Again, we have log base 2 of x squared minus 3 equal log base 2 of 2x. Everything is in logarithmic form, and we do have exactly the same basis. So inside the log expression should be equal to each other. Solve for x. Since we have a quadratic expression, you want every term to be on one side. So I'm gonna move 2x to the left by subtracting 2x both sides. So So we end up with the 0 on the right hand side. Factoring. 1 times 1 makes 1 as a leading coefficient. 1 times minus 3 makes minus 3. 1 times minus 3 makes minus 3. 1 times 1 makes 1. When you add them, you get minus 2, which is coefficient of x we were looking for. So multiplying by x times x makes x squared. You put the parentheses on first row, second row. So first row is x plus 1 times x minus 3 equal to 0. Each parenthesis should equal to 0. Solving for x, minus 1, x equal to minus 1, x equal to 3. Again, do not forget checking final answer against constraint of the domain. So log expression, inside the log expression should be positive. There's another log, so 2x also should be positive. Solving for this, so x squared minus 3, you can factor that out as x plus square root of 3 times x minus square root of 3 is positive. So you got two zeros, x equal to plus minus square root of 3. If you roughly graph it, you got minus square root of 3, square root of 3. Since leading coefficient is positive, you can have open up parabola. You want that to be positive, so you're looking at any portion of the graph above x-axis. So you want y value to be positive and any portion of the graph above x-axis is being positive. So which is the same as minus infinity to minus square root of 3 or square root of 3 through infinity. So from this side, domain should be x has to be less than minus square root of 3 or greater than square root of 3. So we still have this expression 2x is greater than 0. Divide by 2 both sides, x is greater than 0. Okay, this has to be satisfied. This has to be satisfied. So these two relationships has to be AND. It has to be intersection. So if you intersect those relationships, x is less than minus square root of 3, x is greater than square root of 3, and with x is greater than 0, x is greater than 0, has to be AND. Only way it satisfies this and this at the same time is this. So x has to be greater than square root of 3. That's the constraint of domain. So if you compare this, value of x is minus 1 is not satisfied. Minus 1 is not greater than square root of 3. When you plug it in, minus 1 is greater than square root of 3. No. Meaning, you cannot take this as a final answer. So x equal to 3 does satisfy this domain. So final answer is only 1, which is x equal to 3. Solving logarithmic equation with more than one logarithmic form with the same base, but this example has constant. Logarithmic form, this term is not in logarithmic form. So we have equation with a constant in it. We can make that to expression with the logarithmic form. So minus 3 is the same as minus log base 2 of 2 to the third power. That's same as 3. Then we have equation with all logarithmic form. So log base 2 of 2x minus 1 minus log base 2 of 8 equal to log base 2 of 5x plus 2. We can condense these two logs on the left hand side. Log base 2 of 2x minus 1 all over 8 equal to log base 2 of 5x plus 2. We have a logarithmic form with the same basis, left and right hand sides, and their inside log expression should be equal to each other. So 2x minus 1 over 8 equal 5x plus 2. We can multiply by 8 both sides. So 2x minus 1 equal to 40x plus 16. So it would be what? 38x equal minus 16 minus 17 dividing by 38. 38 will give you minus 17 over 38 as a value of x. Okay, so do not forget checking the final answer against constraint. So what's your constraint here? Inside logarithmic expression, so 2x minus 1 should be greater than 0. Another inside expression, it should be and 5x plus 2 should be greater than 0. So solving inequality on first one, 2x has to be greater than 1, x has to be greater than 1/2, and 5x has to be greater than minus 2, x has to be greater than minus 2/5. We gotta end these two inequality. So x is greater than 1 over 2, x is greater than minus 2/5. It has to satisfy both, meaning we are looking for intersection. So intersection will be this region. So we got the domain. Domain should be x has to be greater than 1 over 2. So we got the answer as minus 17 over 38. Does that satisfy this domain? No. Meaning we end up with no solution.